Hello, Year 10. This is a recorded lesson in case you weren't able to make the live lesson this morning. So it's Monday, the 11th of January. So I thought it would be useful just to start by showing you your specifications. You can just kind of recap where we're up to. So we've been looking at rivers, river landscapes in the UK. So this first box here, how a river changes downstream, we've covered all of that. We've looked at river processes, so that's the erosion, the transportation, deposition. We've then looked at landforms, that's waterfalls, interlocking spurs, meanders, etc, etc. And then last week for me in your two lessons, you looked at the River Tees as a case study of a river in the UK. So we're on this last box now here. It's different management strategies can be used to protect rivers from flooding. So it's all about flooding. So I know many of you are very keen to get on to some more human geography. So after this unit is finished, and we're very nearly done, we'll be on human geography. So all we've got to cover this week is what causes flooding. So what physical and human factors can increase the chance of flooding. Then we're going to look at something called hydrographs, which is a way to kind of graphically represent, predict and manage floods. And then we're going to look at techniques for managing floods, and then we'll look at a case study. So I predict 2 weeks worth of lessons, and then we'll be finished. So on to today's lesson then. Hopefully this will work. So we're looking today at how can physical and human factors affect the flood risk of an area. So what different factors make an area more or less likely to flood? And we split it as usual. We categorise things in geography. So we split it into physical causes and human causes. So it's always good to start with what a flood actually is. So a flood or a river flood, we're bothered about river floods at the moment, not looking at coastal flooding, we're looking at river floods. So a river floods when the water normally flowing in the channel overflows its banks and spreads out into the surrounding land. So a definition of a river flood is basically when a river overflows its banks. Simple as that. And I love this picture of a river, real violent river, clearly overflowing its banks here at the front. So you remember, hopefully in class, we spent some time looking at the hydrological cycle, which is the posh name for the water cycle, and looking at drainage basins. And remember, we said a drainage basin is a closed system. So it's basically an area of land drained by a river and all of its tributaries. And we said different factors will affect the rate at which water moves through this drainage basin and reaches the river. When we're looking at flooding, what we're bothered about is how quickly is the rain that's falling from the sky going to get into that river. The quicker the water gets into the river, the more chance there is of flooding. So obviously a river can cope with a certain amount of water flowing through it at any one time. And what we're bothered about in flooding is what factors might increase or decrease the speed at which water gets into that river channel. The more, I suppose, obstacles we can put in the way to stop the water getting into that river, then the less likely that river is going to flood, because it's going to get the water into it at a nice slow pace, and therefore it's going to take longer to kind of fill up, and it's hopefully never going to overflow. So I thought it's useful just to remind ourselves of this diagram and all the different routes a raindrop can take before it reaches the ground. So of course a raindrop can simply flow into a tributary and get straight into the river, and that raindrop hasn't really had a very exciting journey. It's gone from the clouds into the river, and it's immediately helped that river to fill up. In some drainage basins we'll have a lot of vegetation. That's the plants and trees. And when we have vegetation, if you remember, this process called interception can happen. And all that is just as in football where you might intercept a pass and you stop the ball reaching somewhere. Interception in terms of flooding in geography, or in terms of water, is where the trees stop the rainfall reaching the ground. Okay, so talking about interception, and hopefully I can just get, here we go, we can get this one up now. So interception is that process where the rainfall stops the rain reaching the ground. Where the vegetation stops the rainfall reaching the ground. This image shows it quite well. You can see the huge number of raindrops on these leaves, and it shouldn't be underestimated just how much of an impact vegetation has. It stops huge amounts of vegetation reaching, huge amounts of rainfall reaching the ground. Now, of course, these raindrops eventually might reach the ground because the wind might blow the leaves or they might drip off, but it's going to reach the ground more slowly. So if you have an area with a lot of vegetation, it decreases the chance of flooding because these trees or these plants stop the rainfall hitting the ground, and that's going to slow down the time it takes for that rainfall to reach the river. So that's something that can slow down flooding. Now, another important thing to talk about when talking about a river flooding is infiltration, and the fact that some of the water, rather than just hitting the surface and flowing over the surface, some of it will actually seep into the ground. If you might remember, we said the word infiltration is the movement of water from the surface into kind of the soil, and then some of that water can go even deeper down into the rock below. We call that percolation. Now the amount of infiltration that takes place, and indeed the speed of infiltration, can have a huge impact on whether a river floods. And we're going to talk about that in a bit more detail now. So if it's been raining for many days, or even if you just had a downpour and your ground's already wet, then the ground becomes what we call saturated. So the ground can only hold so much water, just like a sponge. You pour water on a sponge, eventually it's going to become full and the water's all going to kind of drop out of it. So saturated ground, even if you think about the football fields by school, when it rains, they get flooded pretty quickly, don't they? That they're almost impossible to use. And this picture kind of shows saturated ground quite nicely. So you can see this water here isn't sinking into the ground because the ground's full. It can't hold any more water. And when we say that, we say the ground is saturated. So when the ground is, flicked on. There we go. When we say the ground is saturated, infiltration can't take place. So when the ground is already saturated, it's already full of water, infiltration can't take place. If infiltration isn't taking place, if water's not sinking into the ground, then it's going to stay on the surface and get into the river much quicker. If it gets into the river much quicker, it increases the chance of a flood. Other things that might impact on whether water can infiltrate into the ground or whether it flows over the surface quickly into the river is whether we have permeable or impermeable rock types. And again, we spoke about this before we broke up for Christmas. And this image here kind of shows for us the two different types. So on the left here, we've got non-permeable or impermeable, as we call it, rock. And all that means is, if this almost as if we put a rock or a segment of soil under a microscope and we're looking at all the individual particles. And in an impermeable rock or an impermeable soil, those little particles are really close. They're really tightly packed together. And so there's no room for any water because there's no room for any water to get through. If we look at the right-hand side of the diagram, and we look at porous or what we call permeable rock, look, the actual particles in that rock are quite big. And so there's lots of space in between the particles for little bits of water to kind of creep down. Remember, this is as if we put a rock under a microscope, okay? So on the left, a type of rock like granite or slate has particles that are really tightly packed together, so water doesn't pass through them very well. It's one of the reasons why I have slate roofs. And on this side, of course, you have really big particles. And so this might be like a sandstone or something where the grains of sand are quite big and so the gaps between them are large and the water can seep through. So if we have a permeable rock in our drainage basin, then that's good for flooding because it means that the water is going to sink into the ground and less is going to flow over the surface. If we have an impermeable rock like granite or we've got a clay soil, then actually the water's not going to go through that rock or that soil very easily, so it's going to run over the top or flow over the top and head into the river. Just a reminder, when we're talking about flooding, we're looking at what can stop the water reaching the river, or what can slow down the water reaching the river. After a rainfall event, the faster the water gets into the river, the quicker or the more likely it is to flood. I think I missed one out. Here we go, infiltration rates. So something else that's important to talk about is infiltration rates. And I've kind of explained it. If you think about saturation, the ground's full of water. And if you think about impermeable rocks, or that there is a degree of permeability. So some rocks will be completely impermeable. And some rocks will be really easy for water to flow through. But there'll also be rocks in the middle where, okay, it's not as permeable as sandstone, but it will let water seep through over time. And so what I'm talking about here is infiltration rates. Some soils and some rocks might take a lot longer for rainfall to fall through. So if you had an intense storm, even if your ground is moderately permeable, actually it might take a while for that water to sink in. So sometimes, it's not just how long it rains, it's how intense that rainfall is. So if you have a really intense storm, the ground takes time to take that water in, and it can't cope with all that water at once. So the rate of infiltration is an important factor when we're talking about flooding. So there's two types of rainfall really that can cause a flood. Rain that just goes on and on for days and days, so all the ground fills up. Or just one of those intensive storms where so much water lands or falls at once that the ground just can't cope with it, and it's too slow to infiltrate it through. Another thing I want to talk about that can increase the chance of flooding or can affect the chance of flooding is something we call relief. Relief is the shape of the land. And so what I'm really talking about here is how steep the land is, or the slope angle. So you look at this picture here on the left, we can see that all the water's gathering at the side of this bungalow, because look at his garden or her garden there. We've got a slope and all the water's run down really quickly down that slope. And I've got another picture of a mountainside. Imagine in a rainfall event how quickly this river fills up. Because guess what? When it rains, due to gravity, that rainfall is going to fall really quickly down that slope. Even if this is all permeable rock and permeable soil, if you've got a slope angle like this, then it's actually the rain is more likely to flow down quickly than it is to sink into the ground. So slope angle is hugely important when we're talking about flooding. So if you have a river, or if you have an area of people's homes near a river and they're at the bottom of a valley, then think just how quickly that might flood in a rainfall event, because the water's going to go really quickly into the river. So I've deliberately talked in general about how water moves through a drainage basin and different factors that kind of influence how water moves through a drainage basin. When we're talking about physical causes of flooding, these are kind of the five we talk about. We talk about prolonged rainfall, so that's rainfall that's happened over a long period of time, so maybe it's rained for many days. We talk about intense or heavy rainfall, so that's like a real sharp downpour. The geology, the underlying rock of an area or soil type can impact or can be a physical cause of flooding. The relief or the shape of the land, and whether there's any vegetation. In a moment, I'm going to be asking you a question and setting you a task to do where you have to explain how each of these can cause flooding, or can be an impact of can increase the risk of flooding. Let's just pick one to give you some help. Let's pick prolonged rainfall. So how can prolonged rainfall lead to a flood? Well, prolonged rainfall can lead to a flood because if it rains over many, many days, the ground will eventually become saturated and won't be able to hold any more water. So any water that falls will make its way into the river, and that will increase the chance of the river flooding. We can pick vegetation cover as well, okay? So, vegetation cover. If you have a river in a drainage basin where there's lots of plants and trees, then that means those plants and trees are going to intercept the rainfall and therefore reduce the amount of water going into the river and reduce the amount of flooding. So hopefully that gives you an example of how you might kind of explain these. Next one, human causes of flooding. Now, I've not really touched on these. Urbanisation is the growth of cities. Let's just think, how might the growth of cities impact or cause flooding? Well, when we build cities, what do we cover everything in? Concrete and tarmac. And if you think about concrete and tarmac and other such surfaces, are they permeable or impermeable? They're going to be impermeable. They're not going to let the soil, the rainfall soak through. That's why on a rainy day, the roads very quickly start to flood. So how can urbanisation cause flooding? Well, by building more towns and cities, we're concreting over more and more soil and natural land, and that's going to make impermeable surfaces, which means the water gets into the river and the river's more likely to flood. You all know what a floodplain is. A floodplain is an area that's naturally there to allow flooding when a river floods. If you build on it, guess what? There's nowhere for the river to go when it floods. Deforestation. Well, if we know that interception stops rainfall hitting the ground and getting into the river, well, what happens if you cut down all the trees? There's no interception. So you can explain them yourselves. So here's your question. This is going to be the assignment you have to complete, the assessment. You're going to answer this question. Pause the video if you need to read it. There's 2 marks for each one. You need to explain for me how each of these factors can increase or have an impact on whether or not a river floods. I've given you an example here of what a good answer looks like and how to set it out. So I've done one for you. Again, you can pause this and read this in your own time. I've also popped a couple of websites on Google Classroom there in case you want any more help. Okay, so this work needs to be submitted today. Here's your task. You can rewatch the video. You've got the revision website and you've got my model answer below. Okay, I'll see you again tomorrow.